Hello, flatties and bowlers, and a big hi from the land down under. Yes, I am in Australia, and here, you know, we are upside down, of course. Yes, indeed, because the world is a globe and we are underneath. And now you might wonder, what is it that keeps my hat on my head? And of course, the answer is gravity! Well, today we're going to look at another one of Mr. Marble's masterpieces. And today he is, of course, a space expert. He's an expert on all things relating to upper atmosphere and space travel. So let's just see how much he knows today.
Mainstream science says not to trust your own senses, as if what you were born with isn't good enough for you to use to interpret your own reality.
Okay, let's trust our senses. Our senses tell us that dinosaur head is moving. How can that be? But we must trust our senses. It must really be moving. Well, wait a minute. Oh, wait a minute. Maybe our senses aren't that good after all. Look at that.
What you need to do instead is just leave it up to people who are more intelligent than yourself to give you their interpretation of reality, and you need to just absorb that and regurgitate that and operate according to what they've told you. But that's not gonna work for a lot of people.
Oh, well, that's clever, isn't it? Don't listen to anybody more intelligent than us. No, we should get all our knowledge from someone dumber than us. And what's more, there are people in this world who go to the trouble and expense, go through all the discipline and the learning to make studies and experiments, and, you know, they dedicate their life to the betterment of humankind. And we should just dismiss all of that. And, you know, these people are the ones that have brought us all the things like mobile phones, air travel, Fitbits, computers, motor vehicles, all kinds of stuff. These are the people that have made stuff happen. And no, we shouldn't listen to them. Instead, we should listen to some dude in sunglasses on YouTube who wants to sell you a t-shirt. Yes!
The way we teach science is you're just some empty vessel and we pour the science into you and then you regurgitate it on an exam.
Like a good citizen, like a good sheep.
We teach science is you're just some empty vessel and we pour the science into you and then you regurgitate it on an exam.
Right.
Whereas science is a way of thinking. It's a way of understanding and probing the operations of nature.
A lot of people are coming back to the conclusion that their five senses are, in fact, the only tools that they really need in order to determine what's real and what's not, what's feasible and what isn't concerning their reality.
So let's see. The five senses are the only tools you need. Right. You know, what about building a house? Oh, how much concrete do you think we're going to need? Oh, I don't know. That looks about right. Oh, you think that looks level? Oh, yeah, mate. Looks pretty flat to me.
Let's have a quick discussion about the ISS. Once you leave the surface of the Earth, you get to a certain altitude and then gravity just turns off. Here on Earth, gravity's supposedly pulling everything towards the center of mass, but once you get up to about, 90 miles or so above the surface of the Earth, suddenly gravity just switches off and you can orbit. Sure, why not?
Yes, that's right. Why not? Here you display a complete lack of knowledge on orbital mechanics. Now, seriously, dude, you need to do a bit of research on the topic that you're trying to debunk. Otherwise, you're going to look like an absolute fool. Well, yes, you do look like an absolute fool. I'm not so sure whether it's on purpose or not. But just a little bit of research would help. So let me spell it out for you. Now, you know how you flatties are always saying, oh, the globe is spinning. You should just be flung off. You're spinning at this breakneck speed of 1,000 miles per hour at the equator. You should be all flung off. Well, how come that a satellite orbiting around being flung off into space is so hard a concept? Now, you know, of course, and you've been told many times, but you totally ignore it all the time. The reason why you're not flung off the Earth when it's spinning is because it spins once a day. Come on, once per day, and the forces are not enough to spin you off. So here, I'll do the maths for you. See this. The spin-off force, which is centrifugal force, F1 is your mass times your velocity squared over the radius. And the gravitational force, which is the one that's holding you down to the Earth, is the GM mass of the Earth times your mass over radius squared. Now, you can look up that stuff. So you can solve this equation for orbital velocity, and it ends up being V orbital is the square root of the gravitational constant times the mass of the Earth over your radius. So it doesn't actually depend on your own mass. So when you get F1 equal to F2, the centrifugal force is equal to gravitational force, a sense of weightlessness will be experienced. Now, gravity hasn't stopped. It's still working. It's still pulling you towards the Earth. And you've got this centrifugal force, which is, I'm not going to go into the complications of it not being a real force. It's what you experience when you're going in a circular path. And then that's flinging you out into space, so to speak. So if the two are perfectly balanced, you're going to feel like you're floating. You're going to feel like there is no gravity. And so, yeah, here we go. Your senses are wrong again because you will still have weight. Gravity's still working. Oh, boy. And we'll get on to the orbital speed in a little while.
So we're supposed to believe that the International Space Station is 250 miles above us, the size of a football field, and it's speeding around the Earth, orbiting every day multiple times, going at the breakneck speed of 17,000 miles per hour, somewhere around that.
Yes, of course we can believe that, because reality fits the model. And remember, I was talking about going into orbital velocity. Well, you already know that 1,000 kilometers an hour is not enough to fling you off the Earth. It has to be much greater than that for a satellite to orbit. So let's look at this in metric. Sorry, guys, but we work with metric. So it's 408 kilometers is the orbit height. The max speed is around 27,600 kilometers an hour. Yes, that is. Sounds like breakneck speed to you, but remember there's very, very little atmosphere. But of course, you know that. So here's our handy little orbital calculator, and we only need the radius. The mass does not matter. So we can calculate how fast it should be going in order to stay in an orbit. And here it is. It's just that's that formula calculated out. So the flight velocity is 7.66 kilometers a second, which if we go back here, that's what's stated speed on orbit. So there you have it. It has to be going that fast to maintain the weightlessness and maintain the regular orbit. And we even got that it's around about 90 minutes. So the reality fits the calculations. Oh dear.
Well, recently I forced myself to watch about 15-20 minutes of the ISS live feed, and during that time I noticed a couple things. Well, for quite some time there was no land. There were no land masses that this thing was supposedly flying over for that amount of time. But I'm just watching that. It just seemed to take a while. Perhaps they were flying over an ocean, supposedly. And the length of the United States from west coast to east coast is said to be 2,680 miles across from coast to coast. Okay, now, as we look at this ISS going at the breakneck speed of 17,000 miles per hour, supposedly, think to yourself, does this really look like it's moving at a speed to where it's going to be able to cross over the entirety of the continental United States in 10 minutes? Just look for a minute. Does it look like it? In my opinion, I'm going to go with no on that one. But, I rely on my own senses, my own common sense, basically, to say, no, it doesn't really look like this thing is going to cross over the whole continent in 10 minutes going at that speed.
Well, he didn't wait long enough for us to see how far the ISS went in 10 minutes, so I did my own little experiment. So here I've got the feed from the ISS, the real feed, and I've taken a recording, and I'm going to check how far it travels across the surface of the Earth. I've only got 2 minutes, but that's enough to multiply that up. So I'm going to forward this until the coordinates change. So right there I've got at 2 seconds, and the coordinates just changed to that. I'm going to plug those two coordinates into this map, 19.727.9, and you can see that we're somewhere in Egypt, and that corresponds to this map, and that corresponds to the view there. You can clearly see there the Nile and coming up on the Arabian Peninsula there. So I'm just going to start this running now for 2 minutes. And while this is running, I'll talk about, I'm sure many of you have been in an aeroplane and you look down on the ground and go, oh, that doesn't look like it's going that fast. But you're going to trust your senses and say, well, no, we're not going at 500 plus mile an hour. I don't think so, because you know that you are. But everybody should trust their senses, right? Well, anyway, I'm sure Mr. Marble has been on an aeroplane and looked down, but I don't know whether he asked himself that question. I don't know, this ISS is much higher than that, so the ground's going to move past what looks like very slowly. But we are going to trust our senses and rely on that? I don't think so. You won't do it for an aeroplane. Why are you going to do it for the ISS? So we're just going to watch this go by, and I've let this run for the 2 minutes just so that you can see there's no fakery going on here. You can see the coordinates running down here. This is a few days ago, when I'm recording this now, and we're at 1 minute 29 now. We're just going to wait and see, because this is what we would do in an experiment. Not say, just look at it for a minute and stop. We'd actually look at it for a minute or two. Does that look like it's going that fast? Well, if you imagine yourself going across the ground at that rate of knots, you're going pretty fast there. So I'm going to stop it now right here. That's 2 minutes of video. We have new coordinates 25.5 north, 33 east, which I've plugged into this map here. And yes, it's in Egypt still. So the picture's moved on to over the Arabian Peninsula, but the ISS is apparently still over Egypt at this time. So I'm going to measure the distance between these 2 points so I can see where that is there, and I'm going to measure distance from here. And I'm going to find it's somewhere up here. That's about where it is. That corresponds. And what do we got? 512, nearly 513 miles, 825 kilometers. Now I'm just going to get the calculator out so you can see I've got the calculator, and that's 513, so close enough, miles in 2 minutes is 256.5 miles every minute. Multiply how far we will go in 10 minutes equals 2,565 miles. That's pretty close to the 2,680 that Daryl says. It couldn't go that far in 10 minutes, but there you go. It did. Wow. His sensors are wrong again. He's trusting them, and they're wrong.
On this supposed live feed. Now I noticed some things. Looked like the solar panels were kind of a little more flexible than you would expect them to be. You know, you see in this one picture, you see the solar panels are kind of straight, and then seconds later, you see them curved. There were points where it was just ridiculous looking. Like, you can tell whatever they recorded this video with was obviously a fisheye lens.
Yes, it's a fisheye lens. So what? You know, these fisheye lenses are used to increase field of view. And what? They're going to say, oh, let's put a fisheye lens in here just in case some flat earther might be watching. I don't think so. Everybody knows it's a globe. Oh, my goodness me. Okay. And here's the kicker. Wait a minute. Isn't this video supposed to be fake? And then why would you put a fisheye on CGI? You can, if you're gonna CGI it, you can CGI with everything you want. You don't have to make it fisheye. And what are you doing trying to debunk a fake video? I mean, the space station's not even up there according to you. So why are you trying to debunk the video that doesn't even exist? Really?
Now, moving along, the ISS is said to be 250 miles above the Earth. That places it in a level of the atmosphere called the Thermosphere. According to online searches, the alleged temperature in the Thermosphere is said to be between 900 and 3,632 degrees Fahrenheit in the Thermosphere, where the ISS is supposedly at.
Oh, yes, so he's played the Thermosphere temperature card. Oh, that is to be expected, of course. It's a favourite of the flatties these days. Oh, look at that. The temperature's so hot you couldn't possibly survive. Well, let's look at the page that he's quoted here. Yes, we've got the same page up here. And look, on the very same page, which he does not show this in his video, of course, It says, is it hot or cold in the thermosphere? And he says, although the measured temperature is very hot, the thermosphere would actually feel very cold. And well, there are technical reasons that are way too difficult for a flatty to understand. But there you go. So Mr. Marble, he's cherry-picked this one fact from the scientists who know nothing, and he's discarded all the other facts. Yeah, very, very interesting, isn't it? Now let's have a look what else it says. The thermosphere doesn't feel warm, even though it is up to 2,500 degrees C because it's so close to being a vacuum. So there, right there on the same page, is evidence that Mr. Marble chose to ignore. Well, maybe he was just that stupid that he didn't go looking for it, which is very, very bad research, or he's deliberately deceived us by not including it. Because, the temperature is a great story for a flatty, but not causing it to heat up at all is not a very good story at all, so let's just leave that bit out. We can just cherry pick our facts to present a false position. Good work, Mr. Marble.
Also, I'd have to conclude from what I've seen that the ISS live feed, it's on a loop.
Here's the problem here. Yes, well, I do hate to break it to you, but that's not the live feed. There's just some idiot put a loop on YouTube and said live feed, and you fell for it. Oh my goodness.